Hi everyone, this is lesson 2. This is mostly a lesson with vocabulary. So this could be really boring and my font is really small, but I'll do my best to try to vary my voice and such. So anyway, let's go through these definitions. This is all in your book. You don't have to copy this down. If you were in class, I would be giving you this handout, so you would just be filling in the blanks. So just try to understand the concepts. And you can look in your book if you want to look anything up. So let's start with the first one. If two lines cross, we say that the lines, and the word we're going to put in here is intersect. Intersect. So two lines, let's just draw two lines. I think I have a nice line tool. I'm going to go out here because I have more room. So here's two lines. These are actually segments until I put arrows on the end. All right, so these two lines, if they cross, we say that they intersect. The place where the lines cross is called the point of intersection. You probably learned most of this before, but right here is called the point of intersection. If the two lines in the same plane do not intersect, the lines are called, so if they don't intersect at all forever and ever and ever, two lines that don't intersect, they would go like this and like this. If they would go on and on and on forever, I'm going to put arrows on the end so I'm accurate. Two lines that never intersect, we call them parallel lines. Parallel lines, they never intersect. And we put these little marks on them to show that they're parallel. Because a lot of times when you write them down, or I write them down especially, they're not going to be perfectly straight. But if you put these little arrow things on, then we know they're parallel lines. If two lines make square corners at the point of intersection, we say that the lines are, so let me just draw that. I'm going to make two lines and they form, they make square corners. Guess we haven't gotten into the word right angles yet. So square corners are right angles. I'm sure that's coming up soon. So we put that in there to show it's a right angle. So if they form square corners at the point of intersection, we say that the lines are perpendicular. The angles made by perpendicular lines, here we go, are called right angles. And that's how we mark it. We put the little box beside it. Right angles. Two right angles form a straight angle. So if we have a right angle here and a right angle here, it's going to form what we call a straight angle. Straight angle. An angle that is smaller than a right angle is called an acute angle. So, you know, it's a acute angle. It's less than 90, it's just a little teeny angle. So this is called an acute angle. And an angle that's greater than a right angle, but less than a straight angle, is called an obtuse angle. Oops. This is called an obtuse angle. Yay, one-page definition's done. Not bad, but we have to go to another one. Hold on, here we go. All right. A blank is a special kind of geometric figure. They are simple, closed, flat geometric figures whose sides are line segments. It should be line segments. So it is called a polygon. A polygon is a special kind of geometric figure. So let me just show you an example of a polygon. Let's talk about what are not polygons. Now with polygons, the sides have to be line segments and they have to be closed. So some ones that are not, they cannot intersect either. So this is not a polygon. These are the nots, not polygons. That is not a polygon, even if it were closed here. This is not a polygon, even though it's made out of line segments, it's not closed. And this is not a polygon, once I draw it, because we have a rounded side, so there's not polygons. Now there's different kinds of polygons. You should know these. If it has 3 sides, it's called a triangle. 4 sides, quadrilateral. 5 sides is a pentagon, 6 sides hexagon, 7 sides heptagon, 8 sides octagon, 9 is a nonagon, 10 is a decagon, 11 is an undecagon, and 12 is a dodecagon, and then after you hit 12, it's just called an n-gon. So if you have 15 sides, you'd say 15-gon. You would say it like that, or 20-gon. So there's also concave and convex polygons. This is an example. I'm going to do a concave one first. These should all be straight lines. This one is concave, and you can see it looks concave, right? Caves in. But the test for it is if you can put a point in two parts of the same polygon and connect it and they leave the polygon, then you can say that it is concave. A convex polygon would look like this. Whoops. There's no way I can put a point. This should be straight. 2 points in here can never leave it, so this is called a convex. So this is concave, this is convex. So a regular polygons, if you ever see the word regular, it just means all the sides are the same. So regular polygons have sides of equal length. So let's just do some special triangles here. A right triangle is a triangle that has one right angle. So a right angle looks like this, a right triangle. It has exactly one right angle. An acute triangle has all acute angles. So let me just draw that. All the measures are less than 90, so I can just pull out my little drawing tool and get a nice one. An obtuse triangle has one obtuse angle. So this is acute, obtuse. I'm starting to lose, I wrote those so small. This is an obtuse triangle because it has, right here, it has an obtuse angle. So this is an obtuse triangle, has an obtuse angle. Acute triangle has all acute angles. Equilateral triangle is actually like the one I just drew up there. An equilateral triangle, all the sides are the same, and we mark it by just putting these little marks beside them. That means they're all the same. And finally, an isosceles triangle. I can use my little triangle tool again. I'll just do that right over here. Why not? This is an isosceles triangle. Here's some things you have to know about an isosceles triangles. Two sides are the same, and the sides opposite the same sides are the same. We call that congruent. We can say they have equal measures or they are congruent. So we're ready for the next slide. Oh, we have some examples. Oh, with scalene. A scalene triangle has no sides that are the same. So I can't really draw that very well. I'd probably mess it up. But a scalene triangle, none of the sides are the same. So let's do a couple examples. I couldn't draw those on here, so I'm going to draw the triangles as we go. And 3 examples. Yeah, I think that's about it. And then we have a couple more definitions and we're done. Okay, so let's draw these. It says find x. So let me just draw this triangle. I'll do my best. You will find that I'm a terrible drawer. I'm actually way better when I'm drawing online than when I do it in class. I think I have to get a big yardstick so I can draw straight lines. All right, usually I get applause and such when I draw anything that looks normal because that's how bad it is. Okay, so that's x degrees, that's 30 degrees, and this is 130 degrees. There we go. And we have to find, which we didn't talk about, I missed this somehow, we have to find x. Oh, here it is, it's right, they didn't introduce it yet. This is a really very, very, very important concept in geometry because it's going to be on the SAT and other places. The concept is the sum, I wrote it right here, the sum of the measures of the 3 angles in any triangle is 180 degrees. So here we have a triangle. These should all add up to 180. So these two add up to 160. So if all 3 have to add up to 180, x has to equal 20. 20. The degree is already there. That's why they don't put the degree here. We're just substituting in for x. So we're finding x, it's 20. All right, let's try another one. I think you guys will like these. Okay, I can use my triangle tool. Not really. Okay, forget it. Let me just draw a triangle. So we have this. Actually, I can use the triangle tool. All right. So here we go. This really helps me to have this tool. Okay, so this one we have, it's an isosceles triangle because two sides are the same. We have y degree up here, and we have x degree and 50 degrees, and we have to find x and y. Now, if you remember what I said in the last slide, that when you have an isosceles triangle, the angles opposite are also equal. So we know x has to be the same. This one has to equal this one, so x has to equal 50 degrees. So there we go. We have two of the angles, and we just have to find a third. So we have x is 50, and y is going to be 180 minus 50 minus 50, and so we're going to get that it's 80. So y is 80. All right, one more. We're doing it. All right, here we have another triangle. This one is an obtuse triangle because it has an obtuse angle, so it's obtuse. So we have 110 degrees, x degrees, and y degrees. There we go. So we're finding x and y again. Here they give us the sides, 8 and 8. So when we look at that, we say, oh, both sides are the same. It has to be an isosceles triangle. So I'm going to put in these little marks to show that it's the same. Now, we know that x and y have to be the same. And my computer battery is going to die. I'm so sorry about this. Hold on a second. Right in the middle of my video, no less. Okay. So x and y have to be the same. So we know that there's 110 degrees already taken. So we're going to take 180 degrees minus 110 degrees, and we're going to have 70 degrees that are left over. Now x and y are the same, so we're going to share it between the two. So I'm going to divide it by 2, and so we're going to get 35. So x and y equals 35. And that's how you do those. Okay, a couple more things, types of quadrilaterals. A parallelogram is a quadrilateral whose opposite sides are parallel. So I'm going to just draw pictures of these for you. Parallelogram is a quadrilateral that has two pairs of parallel sides. So here we go. So we have our parallelograms. These should be the same, and these should be the same. And remember how I said we can show that the lines are parallel by putting these through it. And we can do doubles to show that they go together. So a parallelogram is a quadrilateral with two pairs of parallel sides. A trapezoid is a quadrilateral that has exactly two parallel sides. So a trapezoid looks like this. Ew. I'll try to make those parallel. All right. So that's a trapezoid. It has exactly one set of parallel sides. A parallelogram has two pairs of parallel sides. A trapezoid has exactly one pair of parallel sides. A rectangle is a parallelogram with 4 right angles. So here we go is our rectangle. It has 4 right angles. So we can mark the right angles like this. And there we go. And a rhombus is an equilateral parallelogram. So here's our rhombus. It's an equilateral parallelogram. So that means it's a parallelogram, which means that, whoops, I need a line. So it's a parallelogram, but all the sides are the same. So that means both sides are parallel, but all these sides are the same. Use your imagination. Okay, so we have, these are all the same, like that, and all the sides are, opposite sides are parallel. In the last one, I think, let's see if I have another slide. I don't. Okay, so the last one is a square, and a square is a rhombus with 4 right angles. So here we go. Square is a rhombus, which means it has all the sides are the same, and all the opposite sides are parallel, but it has 4 right angles. All right, I kind of went through that quickly. All the definitions are in your book, so when you're doing your homework, if you get stuck, just look back at the definitions in your book and work it from there. Okay, that's it for lesson 2.